This is section D, building a quadratic from a description. So what we want to be able to do by the end of this lesson is to be able to write the equation of a quadratic relation if we are given some information about it. So that information might be the vertex and another point on the parabola, the x-intercepts and another point on the parabola. We could be given the graph of a parabola, in which case we have to find the vertex or the x-intercepts and another point on the parabola. And then at the very end, we will just review the concept of the maximum or minimum value of a parabola from its equation. So what we're doing here today is in many ways, it's kind of some stuff that we've been doing in the lessons leading up to this. We're just kind of doing it backwards. Okay, so what we have been doing is we started with parabolas in standard form up at the top, and we know how to take a parabola in standard form and get it into factored form. And we do this by factoring. And we did this throughout all of Unit 6-7. We can also take this and we can turn it into what is called vertex form. And we did this in section C, where we learned this process called completing the square. Okay. And we also know how to take something that is in standard form and we can graph it kind of by going into the factored form and then using the factored form to find some information about the graph. So why do we have all of these different forms? Well, factored form and vertex form are useful for two different things. There are two big questions that we want to know about a parabola if we've got the equation. One of these questions is, what are the x-intercepts of the parabola? And the other question is, what is the vertex? And the vertex form, obviously, is very useful for answering this question, what is the vertex? And the factored form is very good for answering the question, what are the x-intercepts? If I have this equation here, y equals 3, x minus 5, x plus 2, and you ask me to find the x-intercepts, I can look at it right away and know that the x-intercepts are x equals positive 5 and x equals negative 2, because those are the two places where the y value, the parabola is going to equal 0. The y value is going to be 0. If you were, on the other hand, to give me a parabola like this one over here, I would have a hard time figuring out what the x-intercepts are from looking at that parabola. But if you gave me that parabola and you asked me what is the vertex, well, I would know, I'd be able to tell you right away that since the values of a equals negative 2, h is positive 4, and k is positive 6, I could tell you right away that our vertex here is 0.46. Whereas if you gave me this parabola over here and asked me what is the vertex, I would have to first figure out the intercepts and then find the axis of symmetry and then figure out the vertex from there. So we use vertex form when we want to find the vertex. We use factored form when we want to find the intercepts. Today we're going to be working backwards from this given information. So we're going to be given the vertex and we want to find the equation, or we're going to be given the x-intercepts and we want to find the factored form. So we're going to need to be able to match up this information with the type of equation that we're working with. So here's the kind of question you need to be able to do. What is the equation of a parabola that has a vertex 4, 5 and passes through the point 2, 1? So let's look first at what is our given information. Well, we are given the vertex is the point 4, 5. And we're also given this point 2, 1. Because we are given the vertex, the starting point for the equation of our parabola is going to be the general sort of vertex form of a parabola, because we have the vertex to work with. So we're going to start from y equals a x minus h squared plus k. And we're going to look to see what kind of information we can put into this equation. Well, they've given us the vertex 4, 5. We know that in our vertex, this is our value of h, and this is our value of k. So we know that h is equal to 4, and k is equal to 5. So we can take each of those values and we can sub them into our equation of our parabola. Ax minus 4 squared plus 5. Perfect. Now the other piece of information is we're given this point, 2, 1. Well, our point consists of a value of x and a value for y. So we can sub the y value in here, so our y value is 1, and we can sub the x value of 2 into there. This will give us 1 equals a, 2 minus 4 squared plus 5. Now the only thing that we need to solve to get our equation here is we need to figure out, okay, what is this value of a? So I'm going to take this equation here and I'm going to first simplify. And I'm going to simplify by, well, using our good old-fashioned bedmaster rules. I'm going to first look at what's inside the brackets. So 2 minus 4 is going to give me a negative 2. Then I'm going to do negative 2 squared is going to give me a 4. And then once I've got it to this point here, I can solve for the value of a. I can subtract 5 from both sides to get negative 4 is a times 4, and then I can divide both sides by 4 to get a is going to equal negative 1. All right. And that a value was the last piece missing from my equation here. So I can write my final equation here is y equals, instead of a, I can put negative 1. I'm still going to have x minus 4, that was my h value, plus 5. So there is the equation of that quadratic relation, or that parabola, in vertex form. So let's look at a similar one here. What is the equation of a parabola that have x-intercepts x equals positive 2 and x equals negative 5, and y-intercept y equals negative 20? All right, let's look at what we are given. We are given our two x-intercepts. X equals positive 2, x equals negative 5. And we are given our y-intercept, okay, y equals negative 20, which as a point is going to be 0, negative 20, because the y-intercept occurs where x is equal to 0. Now, if I'm given the x-intercepts, the starting point for finding the equation of the quadratic, or the equation of the parabola, is going to be that x-intercept form. So I'm going to start from factored form. Y equals a, x minus r, x minus s is my starting point. Now, I know that my x-intercepts have to be x equals negative 2 and x equals positive 2 and x equals negative 5. What does this have to look like, this equation have to look like, so that those are my two x-intercepts? Well, I'm going to have, if one of my x-intercepts is negative 5, I need to have a positive 5 in here, because then if I sub in x equals negative 5, that entire bracket is going to be 0. On the other hand, if my other x-intercept is positive 2, I'm going to have a negative 2 in here, because when I sub in x equals 2, 2 minus 2 is going to give me 0, and that's going to be my intercept. So I'm able to sub that information into my factored form here. Now, I still have this issue that I need to solve for this value of a. But again, just like last time, they've given us this point, an x value and a y value. So I can sub in my value for x and my value for y. My y is negative 20. I still don't know what a is, but x is 0. And I'm going to sub in 0 here as well for x. Now I can do the same thing that I did last time. I can simplify. So I'm going to simplify first by working in the brackets there. 0 minus 2 is negative 2. 0 plus 5 is going to be 5. And then negative 2 times 5 is going to be negative 10. And then after I've simplified, I can solve for a. And I'm going to do that just by dividing by negative 10 on both sides. So I'll end up with a is equal to, let's see, 20 divided by 10 is 2, so that's going to be positive 2. A was my last missing piece in the equation of my quadratic, so I'm just going to put in that value of a, and it's going to be negative 2 oh sorry, not negative 2, positive 2. X minus 2, x minus 5. Put a box around it because that is the equation of my quadratic. In this question here, we're asked to determine the equation of the parabola shown in the graph. They're not telling us any information. We need to read it off the graph. So let's look at our graph here and see what is the given information. Well, let's see. They give us this point, 3, 2, right here. That is the vertex of our parabola. Once we have the vertex, we know that in our parabola, h is equal to 3 and k is equal to 2. That comes right out of knowing what our vertex is. The other thing that they give us is this other point up here, 2 and 5. Okay, because they're giving us the vertex in our parabola, we know our starting point is going to be our vertex form. From the vertex, we know our values of h and our values of k, so we can sub those in. X minus 3 plus 2. And just like last time, this point represents a value for x and a value for y, which we can sub in for our y and our x. So our y is 5, a 2 minus 3 squared plus 2. Just like in the previous ones, I'm going to start by simplifying. I'm working in the brackets first to get the negative 1. Then I do the exponent. Negative 1 squared is just going to be positive 1. And then, well, I don't even need to write the 1, right? A plus 2. And then, of course, I can just solve this for a by subtracting 2 from both sides. A is equal to 3. Once I have that value for a, that was the missing piece in my quadratic equation here. So I'm going to put in 3, x minus 3 squared plus 2. And let's put a box around it to indicate that that is our final answer. Again, we are given the graph of a parabola and we need to determine the equation. So let's look at what information we are given from this graph. We've got a point, 2, 4, which we know is going to give us a value for x and a value for y, but that's the only thing that's kind of highlighted on this graph. So our two routes to solving these problems are to either use vertex form if we're given the vertex, or use the factored form if we are given the x-intercepts. We have to figure out either our vertex or our x-intercepts from this graph. And we're going to do whichever one is easier. So our vertex is kind of, I don't know exactly what the coordinates of the vertex are, but I can see pretty clearly that my x-intercepts here are x equals 4 and x equals 6. because I have those two x-intercepts, I'm going to start from my factored form. And I know that if my x-intercepts are +4 and +6, my equation has to have a -4 and an x-6 in there, x-4 and x-6, because then subbing in 4 or 6 is going to make one of those terms equal to 0. Now I can sub in, just like we've done all along here, I can sub in my values for x and my value for y. My y value is 4. I still have a. The point there is 2, 4, so I'm going to sub in x is 2, so 2 minus 4, and then 2 minus 6. And then I'm going to simplify. 2 minus 4 is -2. 2 minus 6 is -4. -2 times -4 is +8. I'm going to solve for a. So a is going to be 4 divided by 8. Or I could write that as 1/2. So let's just say a is equal to 1/2. A is the last piece in our puzzle here. So our equation is going to be 1/2 x minus 4 x minus 6. That's the equation of our parabola. All right, finally, here we're just given the equation of a parabola and we're asked to state a few things about it based on the equation. So, and we're doing these in a particular order for a reason. So first off, we're asked for the concavity. Well, we're given this thing in vertex form here, so we know immediately that our value of a is -4. Our value for h is -7 because we see a +7 in the brackets, and our value for k is +10. So our first question is the concavity. We know that this is concave down because a is less than 0. Let's put that in brackets. Let's say a is negative. A is negative. We know that if a is negative, it's concave down. If a is positive, it's concave up. Second one, does it have a maximum value over a minimum value? Well, if our parabola is, and I'm just going to draw a little picture down here, if it's concave down, we know that right up here, this is going to be a maximum value. Why? Because it's concave down. Now, we know from our values of a, h, and k what the coordinates are of this vertex. This is going to be the point -7, 10, meaning this vertex here occurs at an x value of -7, and at that point, y is equal to 10. So what is the maximum value of this quadratic? The maximum value is +10. Okay, that maximum value is always going to be the y value of the vertex. Our final question, where does the maximum or minimum occur? Well, we have a maximum, so where does that maximum occur? The maximum occurs at x equals -7. So our maximum occurs at the x value of the vertex. The maximum or minimum value is the y value of the vertex, and it occurs at the x value.